A geometric sequence is finite when its first term, last term, and the number of terms are known. A finite geometric series represents the sum of a finite number of terms in a geometric sequence. It can be calculated using this formula. S sub n is equal to t sub 1 times the quantity of 1 minus r raised to n all over 1 minus r, where S sub n is the sum of the first n terms, t sub 1 is the first term, r is the common ratio and is not equal to 1, and n is the number of terms to be added. However, when the last term and the number of terms are unknown, a geometric sequence becomes infinite. An infinite geometric series represents the sum of an infinite number of terms in a geometric sequence. For an infinite geometric sequence that has a common ratio that is greater than -1 but less than 1, the sum of the sequence can be calculated using the formula S sub infinity is equal to t sub 1 over 1 minus r, where S sub infinity is the sum of the terms, t sub 1 is the first term, r is the common ratio, and is greater than -1 but less than 1. Now let us go to the first example on how to determine the geometric series, or the sum of the terms of a geometric sequence. So example number 1, we have 2, 8, 32, 128, and so on. So we need to determine S sub 9. It means the sum of the first 9 terms of this geometric sequence. So since the number of terms to be added is known, this one involves a finite geometric series. So let n be equal to 9 because we are going to add the first 9 terms. T sub 1 is equal to 2 and the common ratio is equal to 4. So 8 divided by 2 is 4. You can also get the common ratio by dividing the third term by the second term, or the fourth term by the third term. Now let us substitute the given to the formula. So we have S sub 9 is equal to 2 times 1 minus 4 raised to 9 all over 1 minus 4. So we need to get first the power of 4 when raised to 9. So we now have S sub 9 is equal to 2 times the quantity of 1 minus 262,144 all over 1 minus 4, which is equal to -3. Then we are going to subtract this one. So we now have 2 times -262,143 divided by -3. And then we need to multiply this 2 here in the numerator. So we have 2 times -262,143 is equal to -524,286 divided by -3. So when these two are divided, the answer is 174,762. That means the sum of the first 9 terms of this geometric sequence is 174,762. Now let us go to the second example. We are going to determine S sub 7, or the sum of the first 7 terms of this geometric sequence, where t sub 1 is 2 and the common ratio is -2. Now let n be equal to 7. Now t sub 1 is 2 and r is -2. Let us substitute the given values to the formula. We now have 2 times the quantity of 1 minus -2 raised to 7 all over 1 minus -2. So we are going to get again the power of -2 when raised to 7, and then we are going to subtract that from 1. So we have 1 minus -2 raised to 7 is positive 129. 1 minus -2 is positive 3. Then we are going to multiply 2 and 129, so we have 258 over 3. So S sub 7 is 86. It means that the sum of the first 7 terms of this geometric sequence is 86. Now let us go to the next example. And this is the last one. So we need to get the sum of the geometric sequence 27, 18, 12, 8, and so on. If you have noticed, the number of terms to be added is not indicated. That means this sequence or this problem involves an infinite geometric series. Now let t sub 1 be equal to 27, r is equal to 18 over 27 or 2/3. So since this one involves an infinite geometric series, we are going to use this formula. Now let us substitute now the given value. So s sub infinity is equal to 27 over 1 minus 2/3. So we need to subtract first 2/3 from 1. So 1 minus 2/3 I mean is 1/3. So dividing a whole number by a fraction, you have this rule. Get the reciprocal of the denominator and multiply that to your numerator. So the reciprocal of 1/3 is 3. So 27 times 3 is equal to 81. That means the sum of the terms of this sequence is 81. Now it's your turn. Did you answer all items correctly? If yes, very good. So these are the solutions to these problems.